This is MAT 175, Lesson 10, Section 3.3, and we're working with quadratic functions and their properties. With quadratic functions, we're working with primarily either trinomials or binomials, and we're working with the format of ax squared plus bx plus c, where a cannot equal to 0 because then it's no longer a quadratic function. And so we've said in the previous lesson through transformations that when a is greater than 0, then we have, if a is, for example, 3, and so 3x squared, we get that vertical stretching, where in the parent graph of x squared you have x is 1. You put 1 in here for x, you get 1 squared is 1, so that'd be x is 1 and y is 1. And x is negative 1, y is also negative 1 for our parent graph, the blue graph. Negative 1, positive 1. So when x is 3, here we have it 3x squared, that we have the vertical stretching. So when x is 1 now, we get 1 squared, we get 3 out, so that'll be 1, 3. So we get that vertical stretching there. And here we have a fraction, if x is 1/2 x, when x is 1 now, we get y is 1/2. And so it compresses. You get that vertical compression, where it compresses down on that axis. And here we have a negative, so it opens down. The axis of symmetry is like a mirror, and it splits the parabola in half. Here we get the minimum when the parabola opens up. When the parabola opens down, we get a maximum point. And so we have this axis of symmetry that goes through the origin. And it's also, the axis of symmetry is that negative b over 2a. That is also the x-coordinate for the vertex. So here we have 2x squared plus 8x plus 5, and we want to find the vertex in the axis of symmetry. So basically what we want to do here is we factor out the common factor 2 out of the first two terms. And so when we do that, we're going to get x squared plus 4x, but we need that b over 2 parentheses squared here. Well, we've got what we add to one side, we have to subtract to the other side, because we're all on the same side of the equal sign. And since this is a 2 here, we have to put a minus 2, and then we're going to put the b over 2 parentheses squared in here. And so the b is 4, so that'd be 4 over 2 is 2, 2 squared is 4. And so this would be minus 2 times 4 here. And so normally what we've done is we just left it squared and put 2 squared here, and then drop the 2 down, drop the x down, drop the plus down. And so this is completing the square. It's similar to completing the square for a circle, but for a circle we move things to the other side of the equal sign. Here everything is on the same side of the equal sign. And so we get our equation of a parabola in standard form. And from here we can get our vertex HK. So here's our parent graph for our parabola. And now it's going to shift. You should have said to the left. 2 and down 3. So here we also have a multiplying effect of 2, and so that would be across 1 and up 2. So we're going to go ahead and apply our transformation. We're going to shift the x plus 2, that's going to make it shift to the left 2, and it's going to, the minus 3 is going to make it shift down 1. So because of the multiplying effect of the 2, that'll be to the right 1 up 2, and then from the vertex to the left 1 up 2. So that 2 has caused the vertical stretching of that graph. Our vertex is at -2, -3. So notice it's the opposite. So it helps to look at this in terms of transformations. We had to shift this to the left 2, so that would make it a -2, and then down 3, and so that would make it a -3 as well for the vertex. Okay, identifying vertex and axis of symmetry of a quadratic function. Now, if we're just looking at a trinomial and we're not going to try to get the equation in standard form, we can use the equation -b/2a. This part here is when once we find what the x-coordinate is, we substitute it back in to the equation to find the y-coordinate. So here we have our equation, 2x squared minus 3x plus 2. First of all, does it open it up or down? You always look at the leading term, the term that has the x squared in it. If it's positive, it opens up. If this leading term is negative, it opens down. So this one opens up. And we want to determine the vertex by looking at this trinomial. We don't have to use completing the square in this case. We can just use the -b/2a to find the x-coordinate. Our a is 2, our b is -3. So we put minus a -3 here, minus for the minus b/2a. So here's two negatives and they cancel. The a is the 2. So we get 3/4. So that gives us the x-coordinate. It's the axis of symmetry, but it's also the x-coordinate. Well, now we need to find the y-coordinate, so we've got to take this fraction and plug it back into x to get the y-coordinate. And so when we do that, we're going to get 7/8. So our vertex is 3/4 and 7 for x and 7/8 for the y coordinate of our vertex, or h and k. And our axis of symmetry, that's always the x-coordinate of our vertex. Okay, and because a is positive, then the parabola opens up. The quadratic function using a vertex, an axis, and intercepts. Okay, again, here we have the vertex. It opens up and the vertex is below the x-axis, so we're going to have two x-intercepts. Here, the parabola opens up, but the vertex touches the x-axis, so you only get one intercept. So we're using what's called the discriminant, the b squared minus 4ac. When you get more than, when that is positive, when you put this parabola into b, the discriminant, you get a positive number, then you know you've got more than two intercepts. If it's equal to 0, in other words, everything cancels out here, then there's only one. If the discriminant is less than 0, then there's no x-intercepts, because the parabola opens above the x-axis. If it opens up and it's above the x-axis, there's no x-intercepts. Okay, we're going to find the intercepts of 2x squared minus 3x plus 2. The vertex, we're going to use what we determined from the previous example, and we have the axis of symmetry, so we're going to graph that. So we have 3/4 and up 7/8, and now we want to find the y-intercept. Well, that would be, if we put x is 0 in both of these places, we would get a y-intercept at 2. Since it opens up right here, you're not going to get any x-intercepts, so you don't even have to try to find the x-intercepts from there. And we know that the y-intercept is at 0, 2. So it's going to come up and 2, and so the other way is going to be up at 2. So the symmetry of the point with the same y value but 3/4 of the right of the axes of symmetry is both 3/2. So the point 3/2, 2 is on the graph. Alright, and so that's our graph. Determine the domain. The domain is the x value, so what would that be? You should have said negative infinity to infinity or all real numbers. The range, what about that? Well, the range is going to be the same value as the y or k value of our vertex. So that's going to be 7/8, and that's a definitive point there, so that'll be 7/8 to infinity, and that's closed. Okay, the function is decreasing from negative infinity to 3/4, but it's open because we can't increase or decrease from that point. And then it's increasing greater than at 3/4 to infinity. Okay, graph the 2x squared plus 4x minus 1 by determining whether the graph opens up or down, finding its vertex, axis of symmetry, and x and y intercepts. Okay, another thing that we're going to be doing is we're going to have to do completing the square. And I'll show you how to do that. Okay, by determining whether the graph opens up or down. Okay, by looking at the leading term, that tells us the graph opens up. By finding the vertex, okay, we're going to use that negative b over 2a, and that gives us -1. Well, that's the axis of symmetry, right? But we need to find the y value or the k value for our axis of symmetry, for our vertex. What do we do? You should have said plug it back into x, and then we get our k, or our y coordinate for our vertex. So this will be -1, -3. So our vertex is down here. And we know it opens up, so that means we're going to get some x-intercepts this time. Alright, our y-intercept, put zeros in here for x, we're going to get -1 out. So here's -1, -3, and it's going to go through here at -1 and up. But it's going to pass in between 0 and 1 for the x-intercepts. So here's our vertex at -1, -3. There's your axis of symmetry, same as the x coordinate for the vertex. Since a equals 0 is greater than 0, the parabola opens up. Our y-intercept, we said we substitute 0 in for x, and we get -1. So we know we're going to get some x values through here, so it's going to come up like this, but it's going to go in between 0 and 1. So we're going to have to use if we had to find the x-intercepts, then we would have to use the quadratic formula, but they're not going to. Okay, they want the x-intercepts, so we'll have to find that. Alright, and so the x-intercepts, we have to put 0 in here for y, and we're not going to be able to factor it. it's not factorable. So we're not going to get any integers for our solution. So we're going to have to use the quadratic formula. And so the 2, that's our A, 4, that's going to be B, negative 1 is going to be our C. So this will be minus 4 plus or minus 4 squared, minus 4 times 2 is our A, negative 1 is our C, and so that's negative times negative is going to be a positive. So we're going to get square root of 24, negative 4 plus or minus square root of 24 over 4. Well, the square root of 24, that's 6 times 4 is 24, so the square root of 4 is 2. So that'll be 2 square root 6 there, and then you can split it. So let's see what that looks like on the palette. We've got negative 2, negative 2, thicken this up a little bit, plus or minus the square root of 24 over 4. Darken this a little bit too. Alright, well, we know that the square root of 24, that's 4 times 6. I wrote factors of 24 up here. So we know that is going to be negative 2 plus or minus square root of 4 is going to be 2. Square root 6, and then at this point we split it. We split the denominator into 2 parts, and when we do that, now we can go ahead and cancel. The 2 can go into 4, and that's 2 times. 2 goes into that 4, and that's 2 times. And we get negative. Well, 2 goes into itself once. So that'll be negative 1 over 2 plus or minus square root of 6 over 2. And clean this up a little bit, make this look a little nicer. And so that's our answer. And that's what we get here. Now, one thing that you have to be careful with is, let's look at this again. A common error that students make here is, let's go back and let's say we have this. Okay, we simplified this part here, square root of 24, and we got 2 square root 6 all over 4. A common error that students make here is they want to cancel here 2 and the 4 and get 2 here. Okay, well, that is incorrect, because you still have to cancel this 2 here also, and you can't do it because of this plus or minus here. If this is all time multiplication up here, you could do it. So, in a way to get around that is just split it like this, and then cancel and simplify. Okay, and so you get this for an answer that's exact, and they may ask for it as a decimal. But keep in mind, if I wanted an exact form, then if you're asked to have an exact form, then you're going to have to give it in its radical form. Okay, and so where is it decreasing? Well, here's x is negative 1. It's decreasing from negative infinity to negative 1, but it's open. And then it's increasing from negative 1 to infinity, and that's open too. Okay. Alright, and the range is going to be from the y coordinate of your vertex. And that's closed because that's a definitive point there. So it's going to be closed at 3 to infinity. Okay, graph the, here we have a parabola, negative 1/2 x squared minus 2x minus 2. Determine whether the graph opens up or down, finding its vertex, axis symmetry, and x and y intercepts. Okay, it's going to open down. Your a value is negative 1/2, b value is a negative 2. So we have to use that negative b over 2a. So this will be minus negative 2, and then here we have 2 times negative 1/2. Well, the 2's can cancel here, and we get negative 1. And the negatives here can cancel, and that's going to be, those two negatives cancel, but we still have this negative, so it's still going to be negative 2 over 1, or just negative 2 for our axis of symmetry. Okay, but we need to find the y coordinate for our vertex, so what do? You should have said plug that back in to your quadratic equation. And so when we do that, we get 0 out. So this will be negative 2, 0. Okay, and it opens down, so it's going to go this way, down. And our y-intercept, if we look at this, put zeros in for x, our y-intercept is what? You should have said negative 2. So it's going to go like this from negative 2, and it's going to open down. We see how it goes 2 points out this way, it's going to go 1, 2 points out the other way. Okay, and so our vertex is negative 2, 0. There's our axis of symmetry at x equals negative 2. Since a is negative, the parabola opens down, and we get our y-intercept. Okay, our x-intercept, that's going to be at negative 2. Okay, so we have our y-intercept, and it's symmetric about negative 4, 2. So this is 0, so this goes 2 points out, and so it's going to go 2 points out the other way. And so that point is going to, other side's going to be over here. And our x-intercept is just the 1 at negative 2. Alright. Okay, determine whether the domain, what's the domain? Well, you should have said all real numbers, or negative infinity to infinity. And how about the range? Well, you should have said that the range is going to be y is 0. Y is 0, and it's going to go down to negative infinity. But how do we write that as an interval, in interval notation? You should have said from negative infinity to 0, and is that open or closed here? You should have said that it's closed because it's a definitive point. Alright, and it's going to be increasing from negative infinity to negative 2, and it's open there. And it's decreasing, open at negative 2 to infinity. Alright. Find the quadratic function given its vertex and one other point. Okay, so in order to do this, we want to find the equation given just the vertex and one other point. Well, the one other point is usually the y-intercept. Well, we have to use this equation, f of x is equal to a times x minus h parentheses squared plus k. We're going to use the standard form of a quadratic equation. And then we're going to use that. We're going to plug in values, and we're going to solve for a. And then when we do that, we can come up with our equation. Okay, so here we have our vertex at negative 2, 3, and our y-intercept is 1. Well, if our y-intercept is 1, what is the x? What is this as a coordinate? What's the x-coordinate when the y-intercept is 1? Well, that's 0, x is 0, y is 1 at the y-intercept. Okay, so we use our equation standard form. And we know our vertex is going to be, see how this is x minus h? So this would be, when we substitute the h from the vertex, then it's x minus a negative 2. Well, x minus a negative 2 is an x plus 2. So that becomes x plus 2, and you know, you think about it, when you have x plus 2 here, it shifts to the left, you get that negative x coordinate. And then this is going to shift it up, so that would be shifting to the left and up. So that makes sense. That would be x. When we plug the 2 back in, negative 2 back in, it's going to be x minus negative 2 becomes a plus. And now the y-intercept, we're going to put the 1 in for the f of x and the 0 in for x. And now we can solve, because 0 plus 2, that's just 2, so that would be 2 squared is 4. So we've got 4a plus 3 equals 1. So we apply minus 3 to both sides, get negative 2, and then divide by 4. So negative 2 over 4 is a negative 1/2. So our a is a negative 1/2 here. So now we've got to substitute that back in to our the equation of a parabola, and we're going to have just x and f of x left. So we put negative 1/2 in for a, we put in minus negative 2 in for the h, and we're going to put 3 in for the k. And that's our equation for our parabola. And that's our answer. Here's our vertex at negative 2, 3. Shift it to the left, 2, up 3. Here's our y-intercept, 0, 1. Okay. Find the maximum and minimum values. Basically, because this, first of all, you want to determine if this opens up or down. Well, this opens down, right? So that means that we're going to have a minimum or a maximum here. If it opens down, you're going to have a maximum, right? So we want to find the maximum value there. Okay, so since a is negative, the graph opens down and we have a maximum value. So we plug in, we use the negative b over 2a. The a is a negative 1, the b is 4. So that'll be minus 4 over 2 times negative 1. The two negatives cancel, and we get 2 cancels into 4, and we get 2. But that's our axis of symmetry, right? That's only the x coordinate for our vertex. So we got to plug that in 2 in our equation to find the y coordinate. So our vertex is going to be at 2, 9. Okay, and so there's a summary of some of our steps. Now, let's go back here, and what we want to do at this point is, one thing that has not been covered yet is completing the square. So let's say that we took this 2, let's go all the way back, and we're gonna let's say we have here, actually let's start with even more basic one than that. Let's say that we have the equation of f of x is equal to, let's say, just x squared minus 5x plus 3. Okay, what we have to do here is we've got to get it into the form of f of x. We've got to get it into this form of general form. Okay, of f of x equals to x minus h parentheses squared plus k, where the vertex is hk. Okay, the x coordinate of the vertex is always going to be with the x, and that's always the h. So we need to get it into this parentheses squared here. So what we're going to do is we're going to give ourselves some space here. We're going to put in here x squared minus 5x plus b over 2 parentheses squared. And then here we have the plus 3. And now what we added to one side we have to subtract. So we also have to put a minus b over 2 parentheses squared here. Okay? It's like when we have 2. Well, if we put a plus 2 here, we also, or let's use a different number. Let's say we have this. Let's say we have 3. And we, just out of nowhere, we put add 2. Well, in order to get this, we can't just add a 2. So, but if we add 2 and then subtract 2, we still get 3. So that's what we're doing here. If we add a b over 2 parentheses squared, we have to apply minus b over 2 parentheses squared, because they're all on the same side of the equal sign. Okay, so since b is 5, right? We'll make this minus 5x here plus, and so we have to put 5 over 2 parentheses squared, and then so we have to put a minus, and then 5 over 2 parentheses squared there. Okay, now we said before that we keep it squared, so trying to factor this that would be pretty rough. So just like when we did operations with a circle, we drop the x down, drop the sign down, and drop the 5 over 2 down. And so that's going to give us x, what's the sign going to be? Minus, and what do you think is going to go in here? Okay, you should have said 5 over 2. So we're not squaring that, right? We just drop that right down in there. And it does the same thing as when we're using completing the square. Okay, so this will be plus 3, and then 5 squared, that's minus, that'll be 25 over 4. So we need to get a common denominator here, so we have to multiply 4 over 4 here, right? Multiply 4 over 4 to get our common denominator. And so that's going to be x minus 5 halves, close parentheses, squared. And so this will be plus 3 over 4 is 12 over 4 minus 25 over 4. Okay, and so we end up with x minus 5 halves, close parentheses, squared, and so 12 minus 25 is going to be a minus 13 over 4. And so that vertex, okay, now let's look at it this way. Looking at it from here, are we going to shift to the right or to the left 5 halves? Okay, you should have said we're going to shift to the right 5 halves, so that makes this a positive 5 halves. And now are we going to shift up or down for the 13 over 4? You should have said down, so that'll make it a minus 13 over 4. So when you look at it in terms of transformations, it makes it easier to come up with your vertex if you need to do that. But our equation in general, in general form, or in a standard form rather, our equation in standard form right here, and here's our vertex.